Today I'm going to be talking a little bit about the Subtractor polyphonic synthesizer in Reason. Now I'm running Reason 8, but the Subtractor's been around for a lot of different versions, so if you have Reason, chances are you've got the Subtractor, and I just wanted to start out with this one for a little bit of teaching for people who don't really know a lot about subtractive synthesis and synthesis techniques in general. Now, the reason it's called subtractive synthesis is that you at first generate a very rich sound with a lot of harmonic content, and then after that you sort of whittle it down and hone the final sound with filters, envelopes, things like that to give it more character. Now, I'm going to address the oscillator section first because the oscillators are really where the sound is created, so that's where you get your original rich sounds to subtract from. I'm going to start with the oscillators 1 and 2, then I'll talk about the noise one, then we'll move on to other features. So let's get started. Right now I've only got one oscillator active. You can see the other one has a dim light, which means it's not on. If you turn that on, it'll toggle. The first oscillator, each oscillator has 32 waveforms. You've got your basic waveforms like your sawtooth, you've got your square waves, they're all really rich sounds. This is based on some analog modeling, so it's not your typical digital, perfectly sharp saw or square wave. It's got some nice character to it, actually. Propellerhead did a good job with the Subtractor. You've also got your triangle wave, which I really like for subs. It sounds pretty warm for a triangle. And finally, you have your other basic waveform, the sine wave, just a pure tone. And then you've got a bunch of other ones, which are basically variants of the first four with some twists, and they're good for a lot of other sounds. I'll just let you listen to a few of them before I talk about some of the other oscillator features. So here's just a few. Just a little bit different than a saw. Kind of a ringy square. That one's really interesting, actually. That one's definitely good for bells. Has sort of an FM-y feel. And speaking of the FM, you've got an FM knob over here. So if I turn on the second oscillator, you can mix in instant FM. So you have a lot of flexibility in terms of creating your original sound. You can get a lot of harmonics with that FM, with a little bit of ring mod too. You can do that. Now you see I turned on the second oscillator. You can have both active at the same time, but I'm going to turn the second one off for now and switch the first one to a saw just so you can hear what these phase modes do. Now, in default, it's on the off mode, but if you press the mode button, it's going to go to multiply mode, which basically creates a copy of the waveform and multiplies it by itself. It's not a detune feature because it doesn't just add them. This feature strictly multiplies them, and it starts out with a phase difference of 64. So let's see how that sounds. Back to original. So at the 64, there's no phase difference, which means that they're just sort of making the whole output louder. But if we change the phase, you can hear that the multiplying starts to make the sound more interesting. And when we get near the end, it sort of almost disappears completely. And the phase can be modulated down below in the mod section, which I'll talk about later, but that's a nice feature to have. Now I'm going to go to the subtractive feature, and basically what this does, it does the same thing as the multiply. It creates a copy of the oscillator, but instead of multiplying it, it subtracts it. Now at 0, you're going to get, I think, nothing. I was wrong. So this is without any change. Now I'm going to sweep it around, and you're going to hear that at some points there's some phasing stuff going on. You'll see what's happening. Yeah, at 0, there's no sound. It's a perfectly subtracted signal, so there's no output. So you can tell that it's actually subtracting because when they're at the same phase, there's nothing. So that's a good feature. And